What if we've misunderstood time itself? What if everything from our watches to our equations is built on a mistaken identity? Just as centuries ago we confused weight with mass, today we may be confusing the measurement of time with time itself. And until we fix this, our science may remain stuck, trapped by the very language it uses to describe reality. Ask someone what time is and they'll point to a clock, but that clock isn't time, it's a tool. A tool we've built to track change, to compare one event to another. What we call time is actually the measurement of duration, the interval between states. It's not a physical thing you can grab like space or matter, it's more like a ruler, a scale we overlay onto change. We say it's been 10 seconds, but what we're really saying is this amount of change has occurred as measured by a device designed to count change. It's not the first time we've made this kind of mistake. For centuries, people used weight and mass interchangeably, but they're not the same. Mass is a fundamental property. Weight is the measurement of a force, the result of gravity acting on mass. You weigh less on the moon, but your mass is unchanged. In the same way, we've built a civilization that treats measured time as if it were real time. But just like weight is a measurement of a force, what we call time may just be the measurement of something deeper, something we haven't named yet. This brings us to a deeper question: what is time really? Is it a fundamental part of the universe like space and matter, or is it something that emerges from deeper laws? Many physicists now argue for the second option. That time, as we know it, arises from change, from relationships, from entropy. We don't move through time. We generate the experience of time by comparing differences between states. Just like music creates rhythm by spacing notes, time may be a rhythm we experience, not a substance that flows. In the 1600s, physics couldn't progress because it lacked a concept of mass. People calculated using weight, but weight depends on context. It wasn't until Newton formalized mass that physics began to accelerate. Today we may be stuck for the same reason, with time. Our models in relativity treat time as curved and variable. Our models in quantum mechanics treat it as fixed and absolute. The result, a fundamental contradiction at the heart of modern physics. Like weight and mass before, we need to separate time from the measurement of time. Imagine if time is not a fundamental axis of reality, but a byproduct of interactions. What if, just like weight depended on gravity, our perception of time depends on energy, change, and relationships? That would mean we've been coding physics in the wrong language. By chasing clock time, we may be solving for a shadow, not the source, but by identifying a new concept, let's call it temporal mass, we might open a path beyond our current math. Just like moving from weight to mass unlocked Newtonian mechanics, moving from measured time to true time might unlock the next revolution. Time isn't false, but the way we talk about it, the way we measure it, might be as incomplete as calling a shadow the same thing as the object casting it. Just as we had to unlearn weight to understand mass, we may now need to unlearn time to understand what truly underlies the universe's rhythm. Not just to build better clocks, but to build a deeper physics, one that sees beyond the ticking. What we measure is not time, what we measure is change. To understand the future of physics, we must first redefine the past. Subscribe for more explorations into space, mind, and reality.